There's a world so dangerous, so impossible, no one has ever attempted to explore it. It's not in space, not on Earth, but deep inside. We think we walk on solid ground. But dare to travel inside our planet and we'll discover another world. Filled with bizarre creatures that live only underground. We'll see gold form before our eyes. Feel 1200-degree heat inside a volcano. Discover diamonds buried 240 kilometers down. And giant tornadoes of liquid iron. Until over 6,000 kilometers down at the center of the Earth, we reach its beating heart. Our planet can destroy us. Immense forces trapped beneath the surface could explode at any time and unleash hell. Beneath our feet lies our greatest enemy. It is also our greatest ally. We built civilization with material from inside the Earth. Its story is our story. This coal mine in the American heartland is our entry. "15 meters. 45 meters. 70 meters below the Illinois cornfields. Light, life, everything that's familiar, safe, lies behind us. Ahead, darkness, danger, the unknown. This is no ordinary coal mine. Fossilized leaves and plants cover the ceiling. This was once a living forest. Now it's solid rock buried inside the earth. To understand what happened here, we need to step back in time. "300 million years ago, this was a dense, humid jungle. Giant trees towered 30 meters above the forest floor. An earthquake sank the ground level. And turned the forest into lake. Mud engulfed the trees like flies trapped in amber. Over millions of years, the mud turned to stone. The weight of the stone pressed the forest like flowers in a book and squeezed out water and hydrogen. Heat from the core and from the decaying material itself cooked the vegetation. All that's left is carbon. Over hundreds of millions of years, pressure and heat transformed this forest into a giant fossil, made entirely of coal. The fossil forest is 70 meters underground. Thousands of kilometers and trillions of tons of solid rock lie ahead. To reach the core, we'll have to smash our way through the Earth's crust. Through kilometers of compacted rock that encase our planet. 5 kilometers at its thinnest, 70 where it's thickest. Most of the crust is solid, but not all. Nearly 240 meters beneath the New Mexico desert. A natural tunnel. There's something down here. Bats, in their hundreds of thousands. And something else. Ghostly albino bugs that dwell in permanent darkness. With no light to see by or be seen, they don't need eyes. With no sun, there's no need for camouflage. Entire species may exist nowhere else on Earth, except in this cave. We're like invaders in an alien world. We could still turn back. Yet around the next corner, a chamber so vast, an aircraft carrier could park in here with room to spare. This is Carlsbad Caverns in New Mexico. The chamber is nearly 25 stories high, over 500 meters wide. We could be 1,000,000 kilometers from Earth, but for this fossil embedded in the wall. A shellfish, which means these caves, 240 meters beneath mountains and hundreds of kilometers from any sea, were once ocean. $280 million years ago, on the exact same spot as Carlsbad Caverns. The fossil was a nautilus swimming in a warm tropical ocean. The Nautilus, and countless creatures like it, died. Over millions of years, the skeleton filled with mud, and its shell, rich in the mineral calcite, turned to stone, limestone. The Nautilus became a fossil, one of millions. Together they formed a layer of limestone, over 600 meters thick and hundreds of kilometers long. The ocean above retreated and evaporated. The Nautilus was entombed. Rain trickled down from the surface. It mixed with briny groundwater, full of hydrogen sulfide gas, to become acidic, and ate into the limestone. Over millions of years, the water carved out passages and created a network of tunnels and immense caverns. Inside the cave, the water evaporated to leave tiny crystals of calcite. Drip by drip, the calcite accumulated. It grew down from the ceiling as stalactites, and up from the floor as stalagmites. Now we know. All this is made of long-dead sea creatures. Crushed, dissolved and mobilized to form giant columns. Created as a stalactite from the ceiling, met a stalagmite from the ground. And fragile soda straw stalactites. It can take 100 years or more to grow just 2.5 centimeters of these hollow calcite tubes. We could stay here forever, captivated by the cavern's beauty. But we have to drag ourselves away, on towards the core. We're 300 meters inside the Earth's crust, beneath Southern California. The rock has been crushed to pieces here. There's rubble all around us. Clear it away, and we can see why. We're inside a plate boundary, where two giant slabs of the Earth's crust meet. The boundary runs for hundreds of kilometers. It's the San Andreas Fault. It looks calm. Too calm. But speed up time, and it's a different story. Powered by heat escaping from deep inside the planet, the plates that make up the Earth's crust are in constant, slow motion. On our left, the North American plate moves southeast at about 2.5 centimeters a year. On the right, the Pacific plate moves northwest at the same rate. But not smoothly. The plates get stuck as they move along the fault. Slow down time, and we can see the jagged rocks snag on each other. Unable to move, over hundreds of years, the rock distorts. Stress is building. Something's got to give. An earthquake. Waves of energy are blasting outwards, forcing us through hundreds of kilometers of solid rock at up to 12,800 kilometers an hour. Until we're back on the surface. This is Southern California, being ripped apart in super slow motion. An earthquake is a reminder of the violent forces hidden beneath the surface. We dive back into the crust. $60 meters down. 180. 275. This is the nearest thing to visiting another planet. Less than half a kilometer inside our own. A cave full of giant crystals. 300 meters beneath Mexico's Chihuahuan Desert. Some crystals are as long as a bus. They're as soft as fingernails and sharper than razors. The cave is breathtaking, but deadly. At 50 degrees Celsius and 100% humidity, sweat can't evaporate. The body can't shed heat. Moist air collects in the lungs. Cells overheat. After 20 minutes, even with an ice suit and respirator, you begin to drown. $20 million years ago, the cave was full of water. And it was hot, at least 500 degrees, heated by hot liquid rock rising up from deep inside the earth. Over time, the rock cooled and the water temperature dropped. Until 250,000 years ago, it reached 58 degrees, the critical temperature to trigger a chemical reaction. Particles of gypsum dissolved in the water clustered into a kind of crystal forest. Above ground, our ancestors took their first steps out of Africa. Ice ages came and went. Civilizations rose and fell. And all the while, the crystals grew, uninterrupted. A 250,000 years later, miners prospecting for silver drained the cave and broke through to discover one of the world's greatest wonders. "365 meters down, 460 meters inside the Earth's crust. Layer upon layer of rock, each with a story to tell. Marble, made of ancient sea creatures, heated, compressed, and heated again. These layers are the pages in our planet's story, made up of dust, mud, vegetation, even animal life, that was laid down over millions of years. Sandstone, the compressed remains of a long-forgotten desert. As wind and water moved material around the planet, new layers built up above. One layer buried another and another, squeezing the material beneath until they turned to rock. Basalt, once a mighty volcano ground down by wind and rain. This layer isn't like the others. It's thinner and seems to go on forever. It contains an element called iridium. Iridium is rare on Earth, but abundant in space. Nearly 600 meters inside the Earth's crust, a layer of space rock. 550 meters beneath Denver, Colorado, we've discovered a layer of extraterrestrial rock. Once this rock sat on the surface, which means Denver was covered in space dust. It sounds like science fiction, but the reality is even stranger. An asteroid bigger than an entire city. "65 million years ago, it plunged straight towards Earth, to a planet ruled by dinosaurs, where T-Rex reigned unchallenged. He was as heavy as an elephant. His meter-long jaw was engineered for maximum bone-crushing action. And he had no predators. Nothing could unseat this lizard king. But 2,400 kilometers to the south, a storm was brewing. The asteroid struck off Mexico's Yucatan coast. And released the energy of 100 million atomic bombs. At the point of impact, temperatures reached 20,000 degrees Celsius. Hot enough to vaporize the Earth's crust. Every living thing within a 500-kilometer radius. And the asteroid itself. The impact smashed them all into a towering dust cloud. The cloud couldn't escape the Earth's gravity. It smothered the entire planet. A local disaster became a global catastrophe. Across North America, day turned to night. For months. With no sunlight, plants perished. The plant eaters starved. The meat eaters died. The dinosaurs, arguably the planet's biggest, most successful species ever, were finished. This thin layer of rock, 550 meters deep, is a prehistoric killer. 65 million years ago, it killed the dinosaurs and wiped out 75% of all life. This is more than a mission to the core. It's a journey through the Earth's past. A band of red rocks. They're full of rust. How did millions of tons of rust wind up 600 meters beneath Michigan? 3.5 billion years ago, there was a shallow sea here. Home to one of the Earth's earliest life forms. Colonies of living bacteria called stromatolites. As if by magic, these bacteria turn sunlight into food. And in the process, they released a gas. Oxygen. Oxygen transformed life on Earth. It made the atmosphere breathable. And turned traces of iron dissolved in the oceans to rust. This fell to the ocean floor to form layers of iron-rich rock. Today, we mine these rocks, extract the iron, and use it to build cars, planes, bridges, skyscrapers. This layer of rock keeps our civilization standing. Nearly 2 kilometers down, it's a working mine shaft. We're 3.9 kilometers below South Africa, inside the world's deepest mine. No person has ever ventured deeper than this point. We've reached the frontier of human exploration. Intense heat makes it impossible to travel farther. The rock face is at least 60 degrees, hot enough to burn the skin from our fingers. The weight of nearly 4 kilometers of solid rock above brings a constant risk of collapse. But it's worth the risk. The rock looks unremarkable, but it's hiding something spectacular. $2.8 billion years ago, hot water trapped inside the Earth since the planet's formation cracked the rock. The water released microscopic mineral particles. They formed a vein of quartz, and in it, gold. This is real-life alchemy. has captivated mankind for millennia. It won't tarnish, discolor, or crumble. It's exceptionally malleable. A single ounce of gold can be beaten to a sheet 90 meters square. And above all, it's beautiful. Every gram of gold, even the gold in your wedding ring, started life billions of years ago, far from Earth, in an exploding star. In a supernova, an explosion so intense it fused atoms into gold. Microscopic gold particles blasted out into space, mixed with rocks and dust to form our planet. It's this gold dust we mine today, nearly 4 kilometers down. In this mine, most of the gold is scattered throughout the rocks. 1 ton of rock will yield less than a sugar cube of gold. There's something else hidden in these crevices. Tiny, mysterious organisms. Microbes. This is some of the deepest life ever found on land. With no sun, no oxygen or nutrients, these microbes eat rock. And they've got company. These monsters are worms, nicknamed devil worms. They're the world's deepest living animals, and they've only just been discovered. A secret kingdom of creatures, larger and more complex than we'd ever imagined. Possibly half of all living things live inside the Earth's crust. .9 kilometers beneath the surface. The crust is an Aladdin's cave full of treasure and surprise. Over hundreds of thousands of years, microscopic mineral particles formed clusters. Then, something extraordinary happened. Out of a random, turbulent process, order emerged. One silicon atom bonded to 4 oxygen atoms, over and over again, to form a complex framework of 6-sided prisms. The result is quartz, one of the most abundant minerals on Earth. The sand on the beach, the glass in our windows, even the circuits in our mobile phones are all made of quartz. Iron impurities made this quartz purple. It's an amethyst. Sapphires. Rubies. Emeralds. It takes millions of years of wind, rain, and tectonic plate movements to bring them near the surface. But for every gem we find, there must be tons buried, never to be seen. We're nearly 4 kilometers down. Mankind has looked into distant space, visited the deepest ocean, but no human has ventured beyond this point. It's time to enter the unknown. We're deeper than any human has ever traveled. 4 kilometers inside the Earth's crust, beneath the floor of the Gulf of Mexico. Around us, a layer of rock hundreds of kilometers wide, over 1.5 kilometers thick. It's salt. Trillions of tons of salt. We use it to grit our roads, flavor our food. In fact, without salt, we'd die. But how did trillions of tons of salt wind up here, beneath the ocean? "160 million years ago, a vast scorched basin stretched between Texas and the Yucatan. Like Death Valley, it was below sea level and hot. Briny springs bubbled up through the bottom of the basin. In the intense heat, the water evaporated quickly to leave a thin salt crust. Over 2 million years, the salt grew thicker. Until we're back where we started, inside a layer of salt that's over 1.5 kilometers thick, buried 4 kilometers beneath the floor of the Gulf of Mexico. Sealed below the salt, 5.5 kilometers down, a layer of porous sandstone full of a thick, black liquid. We've struck oil. More than coal, gemstones, even gold. This is the underworld's greatest gift to us. Oil dominates our lives more than any other geological substance. And every time we turn the ignition, we do so thanks to a chain of events that stretch back 155 million years. "5 million years after the salt pan formed, there was a prehistoric sea here. Home to trillions upon trillions of microscopic plants and bacteria, plankton. They're the ocean's smallest creatures, and feeding on them was the largest. At 25 meters long or more, this monster, called Leedsichthys, is the largest fish ever to have lived. What the plankton lacked in size, they made up for in volume. Shallow seas bathed in sunlight and bursting with nutrients created perfect conditions for plankton to thrive. Dead plankton formed a thick layer of organic ooze on the ocean floor. Slowly, mud, silt, and sand piled up above the dead plankton, squeezing and heating them into a rich organic rock called black shale. Over millions of years, the shale went on heating and cooking, just enough to turn the dead plankton into liquid. This liquid is full of hydrogen and carbon. These hydrocarbons contain more energy than virtually any other known substance. This is crude oil, a fossil fuel. Like a sponge, the porous sandstone soaked up the oil, and the salt above sealed the oil inside the sandstone, where it stayed, trapped. Until someone found a way to reach it, over 3.5 kilometers beneath the floor of the Gulf of Mexico. All the world's oil, from this reserve to the oil fields of Siberia and the Middle East, was formed in this way. Oil is the remarkable result of an extraordinary journey that leads from prehistoric plankton to the petrol in your car's tank. 5.5 kilometers into our 6,400 kilometer journey to the Earth's core. As we travel through the crust, we realize its story is our story. Oil, coal, iron, salt, gold. Their stories reveal the debt our civilization above the surface owes to the hidden world below. We're deep beneath the Pacific Ocean floor, inside a slab of crust that stretches from America's west coast to Australia and Asia. It's made of dense, uniform rock. But there's an intruder here. Hot, liquid rock, 6.4 kilometers inside the Earth's crust, beneath the Pacific Ocean. Heat from deep inside the Earth drives magma up, forcing it through the crust and into the ocean. As the molten rock cools, it builds an immense underwater mountain range. This is the very youngest land on the planet. The birth of new crust. Older makes way for new. But the Earth isn't getting any bigger. So what happens to the old crust? There's only one way to find out. Follow it. Moving west at about 10 centimeters a year. At this speed, it'll take 170 million years to follow the crust across the Pacific. Time to hit fast forward. We're riding the Pacific Ocean plate away from America towards Asia. The crust is sliding down into some kind of chasm. This has to be the legendary Mariana Trench, the deepest point on the Earth's surface. We're at the trench's rim, 5 kilometers beneath the ocean's surface, far below the reach of the sun's rays. An anglerfish. Like a firefly, it's generating its own light, switching it on and off to lure in its prey. Six and a half kilometers down, deeper into the abyss. Eight kilometers down, we finally reach the ocean floor. But one section of the trench descends even further. "11 kilometers below sea level, this is the lowest point on the planet's surface. The Challenger Deep. Deeper than Everest is tall. Pressure is over 1,000 times greater than at sea level. It would squeeze every last square centimeter of air from our bodies until we were compacted like a crushed car. The trench is where the Pacific Plate meets another of the great plates that make up the Earth's crust, the Philippine Plate. The Pacific Plate is saturated with water. Its rock compacted over millions of years beneath the weight of the ocean. It's so dense, at high speed we can see it plunging beneath the lighter Philippine Plate. This is where the old crust goes. Here, 11 kilometers under the Pacific Ocean, the Earth swallows the old crust. Our planet is literally eating itself. back inside. Make the surrounding rock transparent, and we can see there's molten rock all around us, rising up towards the surface. Molten rock is less dense than solid rock, so like heat, it rises. And keeps rising. This is as close as it gets to hell on Earth. We're inside a vast chamber full of billions of liters of molten hot rock. The pressure is overwhelming. It forces gases and water out of the magma up at high speed, until they punch through the crust to erupt as a volcano. A terrible, beautiful monument to the immense power locked within. Power that can melt solid rock, heating it to over 1,000 degrees Celsius. Blast bombs of lava as big as buses thousands of feet into the sky. And send a wall of 800-degree ash and rock down the volcano at 240 kilometers an hour. Get in its way, and the ash would fill our lungs, burn, and suffocate us. Grit and hot toxic gases would sandblast our skin. The world beneath the surface has the power to blast millions of tons of gas and pulverized rock high into the atmosphere, creating acid rain, blocking out the sun for months, even years on end. And this is just one volcano. There are 600 or more round the Earth that are still active. 3/4 of them sit in a ring of fire around the Pacific Ocean. These volcanoes trace the line right where the Pacific Ocean plate sinks below the continental plate. From here, we can see how it's all connected. The plate, the San Andreas Fault, the mid-ocean ridge, earthquakes, volcanoes. They're all part of the cycle of destruction and renewal that makes our planet dynamic. But there's one cluster of volcanoes that doesn't fit in. Thousands of kilometers from the Ring of Fire, in the middle of the Pacific Ocean, is the volcanic island chain of Hawaii. Hawaii sits in the center of the oceanic plate, far from any crack in the Earth's crust. These islands shouldn't exist. This is the Big Island, home to Hawaii's most active volcano, Kilauea. The volcano erupts along a series of rifts, spewing out up to 500,000 cubic meters of lava every day, enough to resurface a 30-kilometer highway. As it cools, the lava forms land. Maybe this is how the continents were born. As molten rock rose up through the ocean crust and burst out to form mountains, islands, continents. But where does all this lava come from? Three kilometers down below Hawaii, an immense chamber, big enough to feed all Hawaii's volcanoes. Magma surrounds us, reaches down through the crust towards a mysterious layer of rock that separates the crust from the core, called the mantle. It's 2,900 kilometers thick and makes up 84% of our planet's mass. Yet nobody has ever visited the mantle, ever seen it. Until now. "16 kilometers beneath Hawaii, we've broken through the crust into the Earth's mantle. This isn't what we were expecting. It's not liquid, and it's not red hot. The rock is solid but movable, like fudge. And though the temperature down here is 1,000 degrees, it's the intense pressure, 25,000 times that on the surface, that keeps the rock from melting. There are no layers, few landmarks. If we want to find our way to the core, we'll need to see through the rock. Viewed from below, the crust becomes a world upside down, with peaks, troughs, plains. There's a parallel universe hidden inside our planet, an entire landscape that's a mirror image of the world above, inverted and distorted. As we travel west beneath Asia, the crust descends deeper into the mantle. 20 kilometers down, 30 kilometers. Above our heads, the Himalayas rise into the sky. Directly below, the crust pushes deep into the mantle. Everest is 8,848 meters high. This inverted mountain must plummet down at least 6 times that depth, to 70 kilometers beneath Everest's summit. Like an iceberg, the mountain's greater mass is hidden from view as it pushes down into the mantle. This is our last reminder of home. It's time to turn away from the crust, to venture through the mantle. Through the vast, untouchable, uninhabitable bulk of our planet. "70 kilometers down, the Earth's mantle is eerily calm. But the rock is moving, creeping along at 12 centimeters a year. It's moving because it's being heated. The core heats the rock, creating convection currents, just like those in a boiling pan of water. The currents push the mantle rock away from the core, back towards the crust. Then the current pulls the mantle rock along beneath the crust. And as the mantle rock moves, it drags Earth's crust along with it. Since we left home, we've wondered how the tectonic plates move. What triggers earthquakes and volcanoes? The process that builds and moves entire continents. Here's our answer. Giant convection currents. The farther from the core, the cooler the rock. The cooler, denser rock sinks back down. Once the rock sinks, the core heats it up again, and it rises back to the surface to cool. This convection cycle defines our planet. The churning keeps us geologically active. This is the Earth's engine. But the fuel comes from deeper still. "240 kilometers down, a welcome surprise. Clear, hard crystals. Every diamond that sparkles in every ring, in every crown, started life way down here. The rock here is rich in carbon, the same element that makes coal and graphite in pencils. But at 1600 degrees and under 50,000 kilograms of pressure per square centimeter, 50,000 times greater than the pressure on the surface, carbon atoms squeeze into a much tighter arrangement than coal or graphite. It can take up to 3 billion years to create these hardest, most valuable of gems. Natural diamonds only form at this depth, at this temperature, and with this pressure. Humans can't survive here. No drill could reach this far. So how do we mine diamonds? "30 million years ago. gas trapped in the mantle expanded, like a shaken champagne bottle. Diamonds and rocks from the mantle blasted into the crust. Every diamond we treasure was forged in extreme heat and pressure, blasted to the surface in a series of ancient eruptions. The last time, 30 million years ago. Millions more remain, buried beyond our reach. "320 kilometers. 500 kilometers beneath the surface. Kilometer after kilometer of hot, green rock. But make the mantle rock transparent, and we can see there's something different down here. A slab of rock that must be hundreds of kilometers wide. Infrared reveals the slab is much cooler than the surrounding mantle rock. The slab is cooler because the rock is saturated with water, seawater. Just when it seemed things couldn't get any stranger, deep inside the Earth's mantle, we've discovered seawater. In this bizarre world, the deeper we travel, the stranger things get. "500 kilometers inside the Earth. The massive slab of rock is saturated with seawater. There's only one possible explanation. This is one of the plates that make up the Earth's crust. As one plate sank beneath another plate, it carried seawater down toward the core. This is part of the Earth's ancient crust. There are other slabs down here too, intruders from another geologic era. One day, millions of years from now, the crust we live on may end up down here. Our world on the surface that feels so solid, so permanent, is anything but. 660 kilometers down, the slabs are piling up. It's an avalanche inside the Earth on an epic scale. Over tens of millions of years, trillions of tons of rock plunge into the mantle's mysterious depths. The colder material sinks and pushes up rock heated by the core. Speed up time, and we can see the rock rising up like hot wax in a lava lamp. It's forcing its way through solid mantle rock, getting softer and more liquid as it rises. On and up, a vast column of hot rock, at least 1,000 kilometers wide, 600 kilometers tall. The column is big enough and hot enough to burn through the crust, to create a volcano far from a plate boundary. This is how we got Hawaii. The volcanic island chain is at the top of a giant column of hot rock that stretches hundreds of kilometers down into the mantle. But we need to travel down, not up, towards the core, not the crust. We've no choice but to dive back in, down through nearly 1,500-degree rock. kilometers. 600 kilometers. 1,000 kilometers. 1,500 kilometers inside the Earth. We're over halfway to the core now. We've traveled through the Earth's crust, into the mantle's deepest depths. The rock is softer, tackier. We're getting hotter. 2,000 kilometers down. 2,300 kilometers. We're getting closer. Closer to the heart of our planet. 3,000 kilometers down. This is it. The force that carves up continents, powers volcanoes and earthquakes. The pivot around which the Earth spins. The center of the labyrinth. It's time to enter the core. We've arrived. This is the Earth's core. It's molten iron and nickel. So hot, it glows yellow. And it's bigger than the moon. Everything that exists on Earth exists because of this. The heat that creates earthquakes and volcanoes, that keeps the continents moving and our planet active, comes from inside this. It looks like it's snowing. Up. As pressure drops between the core and the mantle, impurities rain out of the core's liquid metal, like bubbles escaping from an open soda bottle. The cooling crystallized minerals settle as dunes on the underside of the mantle. We've only just reached its outer edge. But already the core is more complex, more beautiful, and more dangerous than we'd ever imagined. Towering tornadoes of liquid metal. There are dozens of them. Each one is thousands of kilometers high, tens of kilometers wide. The currents are spiraling up towards the core's outer edge and sinking back towards the center at a speed of about 10 kilometers a year. Slow by our standards, supersonic in geological terms. Speed up time by a factor of 50,000, and things get scary. It's 4,000 degrees down here. Such heat creates these columns of hot metal. Then the Earth's rotation twists the columns into giant tornadoes. Together, the spiraling columns turn the core into a giant electromagnet. It's so colossal, the force field it generates extends far beyond the core, through the mantle, the crust, out into space. To create a magnetic shield around our planet. Protecting the Earth from the deadly solar wind. Without these electromagnetic tornadoes, the Earth's surface would be a lifeless desert. Nothing at all would exist. This is truly the perfect storm. A chance combination of motion and heat that keeps our world safe. Every wonder we've seen, every terror, the core's heat drives them all. We can see the heat, feel it, but we still don't know why the core is so hot. What creates all this heat? The answer lies back in time. Long before the Earth was born. 4.5 billion years ago. Rocks circled the infant sun. As they collided, they released energy as heat. Most of this heat radiated out into space. But a small fraction stayed inside the growing ball of rock. The ball became a planet, and as gravity increased, it pulled the densest elements towards the planet's center. These elements sank, creating friction and heat. And as unstable radioactive elements like uranium, potassium, and thorium broke down, they released even more heat. $4.5 billion years later, wrapped within layers of rock, insulated beneath a blanket of crust, the core is still hot. This heat is the core's greatest gift to us. Everything that makes our world so beautiful, so volatile, owes its existence to this ancient energy source. But our journey isn't over. Right now, it's time to enter the planet's inner sanctum, to tunnel through solid iron into the inner core. The pressure is so intense, it would crush us down and squeeze every element out of our bodies until all that remains is carbon, compacted to a single diamond. After a 6,400-kilometer journey, we've reached the absolute center of the Earth. Two forces have dominated our journey: heat and pressure. This is their zenith, their ground zero. It's the planet's hottest place, hotter even than the surface of the sun. Pressure is 3.5 million times stronger than where we live on the surface. We don't know precisely what the inner core is made of, how fast it's growing, when it first appeared, what role it plays. It's a scientific black hole at the heart of our planet. This is where science ends and speculation begins. But from the unknowable, impossible core come the things that make our world possible. Magnetism that protects our world from the sun's deadly rays and allows life to flourish. Mantle currents that drive the plates around the Earth. Precious gems. Their beauty captivates us. Their properties help power our technology. Gold. Oil. Coal. The raw materials that shape and power our civilization. Volcanoes, continents, our changing, living planet. And life itself. Everything we treasure, everything that makes our planet extraordinary. Everything we can see owes its existence to the one thing we can't see. The core. Unseen, but no longer unknown.